You'll be on in a minute. We're going to try to move this along as smoothly as we can. We got a lot of people using different laptops here. And we've managed to get this one on the screen to start us off. All right, so Gautam is going to start us off with a quick talk about big integers. Thank you, sir. Go.
Okay. Hello, everyone. My name is Gautam Kotian. I am a software developer at Sociomantic Labs, and I'm going to speak to you about large numbers. Note here that this talk has absolutely nothing to do with the D language. I just managed to convince Mike to let me speak, so here I am. So let's get started. Any talk about large numbers should start with a number line, and that's where we will start. So as you can see, a number line stretches from -infinity to +infinity. But infinity is just an abstract thing. It's not like something concrete, right? But in this talk, we're going to speak about concrete numbers. Let's look at some commonly heard large number terms. Like we hear a billion. A billion is 1 followed by 9 zeros. Like, you know, if you speak about like the money of some really wealthy people, you might use billions. Or you may talk about trillions, for example, like the wealth of, like the GDP of nations or something like that. But this is generally enough for most people, right? But we still have names for some other large numbers, like all that. And beyond 10 to the power of 27, we don't even bother naming them because, yeah, we don't really need it.
Well, there was one suggestion called Weka.
Called what, Weka?
I don't remember the exact power of 10.
Okay, good to know well. But then, just because we stop naming them doesn't mean that numbers stop, right? Numbers keep going. So let us keep going, and we shall stop at this number, 10 to the power of 80. Do you know what is special about this one? Yeah, you're close actually. It is the estimate of the total number of atoms in the observable universe. Yeah, I don't know how they arrived at this estimate, but yeah, that's what it is estimated to be. Moving on, one followed by 100 zeros is called a googol, and I think that's what Google is based on, isn't it? Somebody made a typo or something, and now it's called Google. And 1 followed by a googol number of zeros is called a googolplex. Now, just suppose that I have a piece of paper, and I start writing a googol. So I would write a 1 followed by 100 zeros. It would take me, like, I don't know, 3 or a couple of minutes to finish writing a googol. But how long do you think it would take me to write a googolplex? Any guesses?
The universe will finish before.
Yeah, something like that. So imagine that every human being who has ever lived, all they did from the time they were born until the time that they died, all they did was write zeros. We would still be nowhere close to writing a googolplex. That's how long it would take. Let's keep going. Let's say that I want to get from like a smaller number like 3 and I want to advance to a larger number like 27. I could count, like I could go through 3, 4, 5, 6 and reach 27. And this I would do in 25 steps. But if I take it to the next level, I can do iterated counting, which is also called addition. So I could go 3 plus 3 plus 3 and get to 27, and then I would have done this in 9 steps. We could take it a level further and do iterated addition, which is also called multiplication, in which case I get to 27 in just 3 steps. And I can take it one level higher and do exponentiation, in which case I would get to 27 in just 1 step. And this is enough for most people, for most of us, right? We stop here. This is what we are taught at school. But we can go to other higher levels. But then we run into a problem of what symbol to use. For addition, we could use the plus. For multiplication, we used asterisk. For exponentiation, we used the superscript. But what do we do after this, right? And here we have something called Knuth's up arrow notation. This Knuth is none other than Donald Knuth, our algorithms guy. So he came up with this up arrow notation, which is actually quite simple. So if you have one up arrow between like two numbers, is just the second number is, raised to, the first number is raised to the second number. So that's what it is. So using this notation, now we can go to higher level. So you can do iterated exponentiation, which is called tetration. For example, consider this number, 3 tetrated to 5. Actually, no. Actually, let's suppose that there were not two up arrows, there was just a single one. So it would be 3 raised to 5, which is 243. As soon as I add a second up arrow in there, do you know what happens? That number is greater than Googleplex, the number that all humans have been writing, since time began. So just adding one up arrow has had that effect. So this completely humiliates the term exponential increase. But let's go to just 3 tetrated to 3. So you can break it down like that. And beyond tetration, we can go to pentation, where you have 3 up arrows between the two 3s. Or you can go hexation, where you have 4 up arrows.
We're almost to 6 minutes.
I need a couple of minutes more. I'll try to make it quicker. So this number, 3 hexated to 3, is denoted as G1. Let's stick it up here. So there you have G1. Remember how I told you that you add one up arrow and it just escalates like crazy? So this is already a huge number. This is like beyond our minds to wrap around this number. And now to get to G2, I'm going to not add another up arrow. I'm going to add G1 number of up arrows between those two 3s. So this makes that already insanely large number like super insane. And so then I get G3 by putting G2 number of up arrows between the two 3s. And this way we go on to do G4, G5, G6, and so on and so forth until we get to G64, which has G63 number of up arrows between the two 3s. And this number is what is called Grant's number. Grant's number is named after Ron Graham, who's an American mathematician. And it was in the Guinness Book of World Records as like the largest number used for an actual mathematical proof or something like that. It's been surpassed now, but this still remains one of the most famous large numbers. So this is what we know about Grant's number. We know that it ends in 7, but we have no idea what is the first digit. And we will probably never know what the first digit is. So what are the key takeaways? Number 1 is tools above exponentiation exist. The technical term for that is a hyperoperation sequence, which you can read now and then immediately forget because you're never going to need it. The second key takeaway is that mathematicians are weird people, even weirder than us programmers. All right, that's all I had. Thank you.
And Dragos is going to tell us about something about protobuf.
So no DConf without a serialization topic, yeah. So this year you'll get a lightning talk about that. So we are talking about protobuf with D, but very important is protobuf free. So in protobuf free there are some features that are not supported by the already existing protobuf libraries in D. So very short, data serialization is about portable representation, compact representation, but very importantly, extensible and versionable. Yeah. Very short. What are the what is the components involved here? So we have message definition, foo proto. Then there is the protobuf compiler, and I wrote a code generator for D that is used the protobuf compiler that generates the the decode. This will be the foo-d, and this will use a support library. This is the protobuf-d library, and of course below I have the application that use everything of that. Without application, makes no sense to have support for that. So there is a definition of such a protocol buffer message. You see there, probably you could identify what this is, and then here below is how to invoke the code. So you specify the message definition, then you say you want to have decode. Here is the out in the same, and then you plug in also the decode generator. The API is very simple. So you take a value, you get back an auto. This auto actually is a input stream that afterwards you could store it somewhere, and you have the corresponding function that reads an input range and then stores the value into the result that is returned there at the, as return type. It is possible to specify, if you want to merge with an already existing data structure, you could specify it as a second argument. Exactly, and now in protocol buffer 3, there is also JSON support. So I also added that. So because of that, instead of the input range, you use JSON value. Another addition to protocol buffer 3, there are the well-known types. Well-known, of course, for the for the protocol buffer people. Very interesting feature is there are a couple of probably about 10 special messages defined, and with implementation, it is also actually a very interesting feature. Is that, for example, the duration, the standard duration message maps to the hour core time duration. The timestamp matches maps to the standard datetime type. And there are also wrappers for the simple types as objects, and they map to the native types using the alias district. These are the open points. So I want to do some benchmarking, and there are some other specialties that could be implemented. And if somebody wants to join me at during the hackathon, I'll be happy to work together with you on completing the implementation. That's it.
All right, thank you, very good. All right, so now Jean-Louis is going to talk to us about Lisp macros. It's the HTML, right? Yeah. Plug this. Yeah, okay.
So I'm going to talk a bit about Lisp macros because maybe we have something to learn from them. So indeed, we have two types of mixins. The mixin templates, they're easy to use, but they're fairly limited because all you can do with them is to create declarations. You couldn't create an expression, for example. And then we have the mix, and also we have to say mixin in front of a mixin template, even though the compiler knows it's a mixin. I don't know why. And then we have string mixins. They're very powerful, but they're sort of messy because you have to build those strings, right? And you cannot always use them anywhere. For example, you cannot replace int I with mixin, quote, int I. Each time I have to use string mixins, I try to use it in the narrowest location, and then I expand it until it works. So I'm going to show you a case study of macro writing in Lisp. But first, a crash course in Lisp. Okay, don't panic. We're ready. Function calls. It's very easy. You simply move the left parenthesis a bit to the left and you remove the commas. You're good. That's a function call. Let. It creates a scope and it allows you to define variables. So here I create a scope. A equals 1, B equals 2. The scope is limited to the closing parenthesis and I evaluate an expression. Plus AB returns 3. Indeed, it would look like this if indeed everything were an expression. List literals. So if I just say foo AB, it's a function call, right? But if I say quote parenthesis foo AB, it's a list made of foo A and B. Now, they have a very convenient construct in Lisp, which is called the backquote. And who has programming shell here, or Perl? Yeah, most people. So you know you can, in shell, you can create a string which is constant, except that you can substitute, inject variables in it with $ something, right? It's exactly the same thing. If inside a block which contains A equal 1, B equal 2, I evaluate backtick foo, well, instead of the $, I use the comma. If I evaluate backtick foo, comma A, comma B, foo remains foo, it's a literal, and comma A is replaced by the value of A, which is 1, and we get the list made of foo 1 and 2. Now, this is convenient to build bits of programs, because in Lisp, a program is an AST, is a list. Here's a min function in Lisp. This is just a normal function, right? If I call min, passing it expressions which may have side effects, the value of the first argument will be bound to A and be evaluated once, same with B. And we all know the problem with C-style macros, min of x++, y++, it may have side effects. So let's try to see how it works in Lisp. So in Lisp, macros are defined with def macro. And they are merely functions that takes a series of ASTs and return an AST. When a compiler says a function inside a Lisp function, which is says a macro call inside a function it's compiling, it stops and it just evaluates the macro function on the spot and replaces the call with the result of the call. So we would want a function like this, define foo AB, which prints the minimum of two expressions. We want foo to, in fact, be this. So we want mmin to be a macro, which is going to substitute the call to mmin with all this. Here we say if left is smaller than right, we return left, otherwise we return right. Let's try. Well, it's quite simple. We can use that backquote construct. We simply write the program we want to return, and we replace small bits of it. So if we write this, so comma A is going to be the value of A, an AST, a list, likewise with B. And I wrote this in Emacs Lisp, and it has a little gadget which expands a macro. So here I ask it to extend the macro call to plus mmin plus A1B, and indeed this is what it produces, right? So what with the towel? It's because Lisp macros, Emacs Lisp macros are not hygienic. It means that if the names left and right here, they may conflict with names which are already present in a context. Okay, so typically a real Lisp macros would look like this. So first we create two new symbols using gensim. which are symbols which are guaranteed to be unique. We assign them to left and right. And then we use the value of left, which is a symbol, a string, and the value of right. And expanding this
We're at
gives
6
us
minutes.
this code. Okay, that's it.
Thank you very much. All right, and now Andreas is going to talk to us about some crazy C++ template stuff, I believe he said. Yeah.
Okay, so time was nice. Who has done some C++ 17 already? Oh, too bad. So you will only see some stuff you already know, I hope. So what we want to do is to make a compile time value. So one of the new features is of C++ 17 that you can now use auto in templates. So we have a v that is a value at compile time. Now we have a struct, and the value is obviously the big V. The type is the Decode type of those. And now an interesting thing, we combine all the keywords you have in one line. It's basically an operator auto. This will convert or deduce the return type from our body of the function. So, and now we can use it. We define a value 1, which is a type, obviously, and another 42. And now, to make it interesting, we want to make an operation on this, so we define an add. So, notice the symmetry in the body of the value. It's necessary. And now we can define a function that's obviously returning 43. Totally cool, isn't it? And now let's do something better, because C++ is awesome, and do it with this, and we get an error. Because obviously floating point numbers are not compile time values. Or something like a string gives us a different error, but it's not working. So what do? We need a solution. C++ has all the solutions. We make a template specialization. This looks more awesome because now you get a function pointer as a template argument. And obviously the value is then the evaluation of your function. The type is still the type of the value. And the operator is as awesome as before. So, and now we can define our pi using a lambda and just add a plus operator in front of it. So we force a conversion of the lambda to a function pointer. And this works. And now we can also do a hello. And we can generalize our sum, adding some dots. And yeah, it basically works as expected. So when we use it, it's, what's the result? I don't, okay, thank you.
All right, thank you, Andreas, and thank you for finishing so quickly. And Nicholas is going to tell us a little bit about decompute now. Yeah, we already got an adapter here, but yeah, sure. Wait, is there an HDMI on there, or is it? Okay, there you go. No, no, no. Just, yeah, here's your HDMI cable. No, no. All right, you're on. Wait, you're on. You're on. Yeah.
No, I'm half on.
Oh, you're half on. Anybody?
That's what I do.
No.
Okay, somebody else has to be all of them.
Thanks anyway, Nick. We have HDMI right here. All right. And Stefan's going to give us an update on new CTFE.
Is it that it doesn't show up again? I'm on? But with what? Oh, right. Great. What? How do I start that damn thing? F5? Was it F5? Yes. All right. An update on new CTV. What happened since DConf 2017? And I'm going to start with the things that I couldn't finish at DConf 2014. And one of the things that I couldn't do in that talk, because I ran over time by like forever, was to thank people that really were influential in new CTV getting done. And the first person is actually Yuri. I have no idea how you pronounce that name, but it's probably he is the Bitcoin guy, right? And he was really influential by basically insulting me for an amount of time, and after that I got my shit together, and I had a very different opinion of testing before meeting him and after working with him and having a really big argument and a lot of bad blood. I finally understood why he was that insistent on code that was tested. All right. The second thanks go to Martin Novak, who helped with reviews and design advice. And there is a person called Alex Icahn who has a free compiler course online on Coursera, which is a pretty good compiler course. So thanks go to him as well, and to the D-Language Foundation for funding. I would say for support, but there wasn't that much. Now, the feature coverage increased since 2017, was it? Yes. We now have working end-to-end and OR, which properly short-circuit, which was not as easy as it should have been. And virtual methods work now, which totally wasn't easy, because for CTFE you don't want to generate a ton of functions, because functions are pretty expensive in my model. And the thing with virtual functions is you only know if you need them after you needed them. So I needed to build a functionality that allows you to defer the generation of a function, but still make it look like you hadn't deferred it, which is funny. The dynamic casts of classes work now, which is a horrible hack that uses the pointer of the vtable to fake class info, because I can't generate class info at that time. And length limited pointers to slices work now. So you know, maybe you know in UCTFE, when you try to slice a pointer that you got from an array, because it's the only way that you can get a pointer that you can slice, and you go over the length, the pointer itself will still retain the length information. That works now. Was pretty easy to implement, but I had to change the whole ABI, which means implementing was easy, debugging was a nightmare, and concatenate equals is now much faster than before, just by allocating 64 megabytes at front and just filling it up. So we can avoid copies by massively overspending the amount of memory we use, which turns out to use less memory overall. It's funny. One feature that I'm currently implementing, and I don't have much time to talk, so I'm going much faster now, is CTFE debugging. And CTFE debugging is actually very nice. It helped me a lot debugging failures in the compiler, like in my CTFE engine itself, because now I can step through compile time code and see values and set breakpoints and evaluate expressions and modify variables, and that's thanks to GCC JIT, which is an awesome effort by David Malcolm, who I'm really indebted to, because his compiler API is the nicest thing I ever worked with. It will actually tell you that you made a mistake at the point you made the mistake, and not 20 function calls afterwards. That's super nice. There's still a few missing features before we can actually start rolling out new CTV. I know, please. It's the last slide. We need delegate support, because delegates in Phobos are everywhere. You maybe don't notice this, but there are context pointers everywhere. Without that thing, you can't do anything if you use Phobos. And there are tons of edge cases in existing features which I don't even want to go into, because then I start to cry. And there's another thing for new CTV. You can help me by, for example, coding. You can try to talk to me and look at the code and try to make improvements, or with proofreading comments, because I am not really good at spelling and the compiler doesn't seem to be either, and it doesn't check them. Or you could go and have a beer with me, which boosts my morale to continue working on it. Or you can provide test cases for me, which I'm always happy for. Just try it, and as soon as you get a seg fault, take that code and ship it to me. And or just discussion, like let's talk about your ideas for CTV and what we can do, because it's now much more extensible than it used to be. And now I'm done.
Thank you, Stefan.
Thanks.
All right, Zabo is going to talk us about, what is it, trial? Trial, okay.
Hi, I'm Bogdan, and I'm also the author of the Fluent Asserts library. The other thing that I did related to testing is a test runner, which is not very performant. If you are looking for performance, you should go with unit-threaded. But if you are looking for customization, you should really have a look at this project. So how does it work? If you have a dub project, so if you have a dub project, instead of dub test, you just call this command. It's local build, and it will run the test. So now I will run the trial command with the clean vibed project repository, and I will run the test for the data sub package. So I will have a nice spec report with all the tests, and what's nice is that if you commented before a unit test, like a name of the example, you will see it as a test name. So you can customize it very nice. I will use this repository by using some interfaces. Everything is documented. So here I have an example for some other reporters. This is a progress bar, for example. And you could use also this kind of wacky stuff, which will emulate a plane crash if your tests fail. But yeah, my tests are passing. So some other things that you can generate are nice code coverage reports, which shows the coverage for your files, and it will ignore the dependencies. This is the documentation with the list of all reporters. You can use third-party reporters like Allure, and you can see here we have all the test suites with the tests and the duration. There is also a built-in HTML report that you just can add your company logo and it will be ready for your CI. It has support for various attributes like flaky, bug numbers, and so on. And the last feature that I want to show you is the plugin support that you can use projects that are in the dub repository without adding to your dub file. So I have such a plugin here, which will color my keyboard as a progress bar. It's compiling. Now you can see it's turning to green as the tests are passing. Thank you.
Thank you, Bogdan. Where is it? HDMI? Take it away, Walter.
Hi, everybody. I'm Walter. I'm from Switzerland. My accent is from Chicago. And I'll be talking about array language development. It has something, but not entirely, to do with D. So most of the time when, well, at least lay people talk to me, instead of asking me things like, are you still using Yak? They ask me, why bother? Why are you bothering with this? What is that with you to have to create another language? There's so many already. And my response is, well, no computer language is perfect from inception, like certain literature from a religion, you know, and find a need and fill it. So what I need in my consulting is an embedded array language, which I can use in a lot of different contexts, one of which would be, for example, in Excel. You remember Excel with its, you know, language to fill up cells and things. If that were an array language, a real array language, it'd be a lot easier. SAP HANA has this thing called Bring Your Own Language. Not sure what that is, but it sounds promising. Domain-specific language, which is basically kind of a cut-down interpreter. I could use that in many different places. For time series graphics, in the statistical community, this SDMX thing is rather popular and interesting, and I think another place to use this. Further, we have a lot of data scientists, and that whole industry seems to be growing rather rapidly. And finally, last and certainly least, at the end, I want to compile this. I want to at least emit some decode, not just calls to subroutines, but true, you know, code, which compiles and presumably runs much, much faster. So some well-known array languages, MATLAB, RNS, NumPy. APL is what I worked on, and the gentleman to the left of that block is Ken Iverson, who basically developed that in the 50s. He passed away in 2004. One of the problems with this community is that they tend to go a little bit crazy on the terseness. So as you can see, Einstein's been paraphrased. So APL has got, you know, many, many years of many, many complaints, funny symbols, in a word, ужас. And all of this stuff, basically the thing APL kind of soldiered on until around 2010, in my opinion. There's still some users of it, but it's mostly history today. So, but APL, of course, had its good parts. And amongst other things, if you accepted all the nonsense, like the funny characters and the strange rules of execution, you had a 15-minute learning curve at least to get started. It had a wonderful array model. It encouraged brevity. I mean, it could go too far with that, of course. REPL, one of the first REPLs was APL. Call by value was also a big thing in APL. Computable Booleans, you could do a lot with APL's Boolean data type. And brevity, I think this is the textbook example, +/arg instead of the usual sum code. I've tried to make some mistakes. So why D? Well, freedom. And I don't think there's any point really in talking too much about this, preaching to the choir and all that, but I think that D is the thing that really made me want to start with this, because I couldn't really didn't feel like doing this in C++, certainly didn't want to do it in C, and had enough. But D was really the thing that opened the door for me here. And so projects that I'm currently working on with this technology, everything here with a little check mark I can show you. They're pretty crude, but I'm always sitting in back there, and you can come by whenever you want. Oh, great. Be that as it may, everything here is under development and can be shown to a certain extent. So that's it. Domo arigato.
Thank you very much, Walter. Simon? All right, Nick's going to try again. All right. Wrong screen again. All right. Thanks again, Nick. Simon, come on up. Okay, anybody here ever heard of a game called Licks?
I have to reboot the machine.
Okay. Shahar, you want to come on up? Shahar's going to take like 2 minutes, right? Hopefully. Okay. And I have no idea what he's talking about.
Well, it seemed to me that we've been teasing you with this Mecha thing since more or less the beginning of the conference, and it got to the wrong screen. Just a second. So I figured maybe we'll just speed up, because I planned originally to release it during my lecture on Saturday morning, but since a lot of you will not be here on Saturday, and I will use it in non-full screen mode, since a lot of you will not be here on Saturday, I wanted to do this very brief announcement, which is that we're actually released Mecha. And let's very briefly what it is, because I only have 2 minutes. Mecha is essentially taking the Weka support library. Everything that Weka does in order to do what it does that is not part of the business logic of creating a storage system, and separating it into a library, both for internal reasons, because when something is an external library, you tend to mess with it less, and you create less technical debt. And once it was there, we said, hey, this code is there. We worked really hard to debug it, to get it up to speed in terms of the performance. Why not let other people, and it doesn't contain any of our sensitive information, any of our sensitive business logic, why not let others use it? So we have released it. Actually, today I uploaded it during the lectures. I wasn't very concentrated, I'm sorry. Released it under the Boost license. It even has a dub package. It actually works. With that said, Mecha has been written so far targeted at Weka. So it mostly focuses on what we need from it, which means that for now, it only works on Linux, it only works on x86 64. And I made every effort to have the API ready. In fact, I delayed the release so that I can make some last minute changes before I release instead of after I release, things that break the API. But there will be API breakage, at least in the near future, because once you start using a library, you discover things that you didn't know before. GitHub.com Weka.io Mecha. And the website, that address has a link to a documentation. With that said, the documentation is incomplete, which is, I think that shouldn't surprise anyone. It actually, at least the reactor part is fairly well documented. And this is an API documentation. This isn't a tutorial how to do stuff. And for that reason, I wrote this very short program which doesn't do anything. In fact, it fails, it returns 42. But what it does do is point you to which APIs you're supposed to look up at the documentation to get you started. And I will post the presentation later.
All right, thank you, sir. And those of you at the hackathon on Saturday can hear his full talk at 10 a.m. to kick us off. All right.
Hello, my name is Simon Ammann. I'm the author of Leaks. Sadly, my laptop's connector broke just now, therefore no UML slides. I will have to make up with UML showed by hands. This is a class. Leaks is a game inspired by Lemmings. It's a free and open source game. It's in the public domain, really. And I'm the author of it. I've been writing it in D for a few years now, and it involves little characters walking over a landscape and doing things. You can click on them, so they do different things. For example, create bridges or dig holes, or smash other leaks with a baseball bat, so those others will then fly somewhere. And you can play this in multiplayer. Up to 8 players can play simultaneously, only assign jobs to their own leaks. And then this job assignment gets sent over the network to all the other players, which then, because it's a real-time game, go back in time, have to insert this extra action into the replay or a journal, and then recompute the physics from there. And it works really well. And, well, we have a ton of leaks on the screen, up to 1,000, and each leak has a job. And because I like object-oriented programming, it's a game with a UI. It's a natural fit for object-oriented programming. I have a lot of classes, and I don't want to new 2,000 times every time the game state updates. Therefore, I've tried to come up with a slight improvement of that. So we have the one class is the game state, has a dynamic array of class leaks, and this class leaks has a job, which is a dynamic hierarchy. Here's the baseball batter, here's the builder, here's the digger. And the job changes the leaks at runtime with the state pattern. These jobs all have different values in them. Some don't have extra values, some do. For example, the builder has to keep track of the number of bricks that are still to be built. Now what do? If we have both of them as classes, we have to new all the leaks and then new all the jobs with every safe state that the game tracks internally to implement the networking. What do? Inside the leaks, I reserve a void array that is large enough for all the structs, for all the classes, for all the implementations here, and then emplace the job into that leaks class, and then I change the leaks class to a leaks struct, and have those structs in the game state as an array. They're all next to each other. Everything is now a value type. They can be mem-copied to make a safe state very fast. Even the regular computation of the physics became 1.5% faster, and it's even faster when I have to new and delete everything all the time. But that is hard to measure because that depends on how exactly the networking game goes. So it's quite an improvement. It breaks the type system though, because now some jobs can access the memory of other jobs if we're not careful. I accepted this optimization still because there are no pointers in the job sections that are exchanged. So if we accept that, then we can still call it safe enough for a game as an optimization. And in D, it was really easy to refactor a class into a struct and then this into a void array where we emplace it. All we had to do was every user had to replace the class references to the leaks with a pointer to the struct, and the code still compiled. Very easy refactoring. I'm happy with D. This would have been a pain in C++, and I'm happy that I've learned better object-oriented design and better refactoring with D. Thanks you very much.
Thank you. Thank you for that interpretive dance. That was good. All right. Oh, okay. All right. All right.
All right.
Nick's going.
So I'm just going to give a recap of what's happened since last DConf presentation about Decompute, which is a sort of library and compiler extensions to LDC in order to run GPU, code on the GPUs. The good news is you can now do that. And you can do it sanely without convoluted mess of code trying to pull your hair out, trying to get the API to do what you're wanting to do. Unfortunately, I forgot that multiple screens on OS X don't like projectors, which is unfortunate, because it's just a web. I was just going to show some code, but you can launch a kernel in a single statement, which might not sound like a whole lot, but when you consider what you have to do otherwise with the things, it's loops and enums and void pointers and untyped, mock-typed arguments to opaque pointers, classes and stuff. There's still a couple of things I want to do before I sort of consider it somewhat usable. I need to make sure that I add testing to it because as Kai discovered when he gave a talk at FOSDEM, I missed a brace and completely missed it. What else was I going to say? The other things I want to do is add contracts to the API because the API that's being wrapped has a bunch of contracts and they're not at all obvious. I do, however, catch the error codes that you get back and throw an exception, so at least you know something happened. But you then have to look up in the API documentation of which function got the error and look up what the error code was and then what conditions could lead to that error. So I think that's going to sort of make it a lot more beginner-friendly in terms of you're going to make mistakes. I've made mistakes trying to use it, trying to create a buffer, and why is this not working? Why is this not working? Oh, I need to set a specific set of flags in order to do this. What else was I going to say? Testing, contracts. I've forgotten. Anyway, key takeaways, you can now actually use it and not go crazy trying to pull your hair out, trying to use a C API and write code for GPUs and have it run.
Thank you, Nick.
Not segfault.
All right. Well, went a little over time there, but thanks for sticking around. And for those of you who won't be here Saturday, you can submit ideas for projects you would like to see people work on at the hackathon to me, to my email address, and I'll make sure somebody, I'll try to find somebody who can coordinate that for you. All right, thanks. That's all. See you guys tomorrow morning. Breakfast at 9 o'clock. Be here at 10. Bye-bye.